Hello guys, welcome to my channel and welcome to the series of deploying on AWS Cloud by using Terraform. If you are new to my channel, don't forget to like, share and subscribe my channel right away.
Hello guys, welcome back to the series of deploying on AWS Cloud by using Terraform. So this is part 9 in which we are going to deploy AWS relational database onto AWS Cloud by using Terraform. So let's go ahead and see what is the agenda for today. Okay, so the agenda for today is first we will have a quick overview about AWS RDS, that is Relational Database Service, what exactly this service is, what are the offerings that this service caters for us, how it is going to help us in terms of database provisioning and all further activities that needs to be performed, kind of maintenance, monitoring, this kinds of activity. Then we will move ahead and understand the prerequisites. What are prerequisites? The prerequisites would be what things should be already available onto your AWS Cloud account before provisioning the RDS that we are going to do today. So once we understand the prerequisites, then we will go ahead and we will start configuring and deploying our resources. So what we are going to do is we are going to create 4 resources. The first one is security group that we would be creating for the RDS instance that we are going to create to control the traffic which is coming in and which is coming in. Then we would be creating RDS subnets where we would be mentioning that which are the specific subnets that we would be targeting for our RDS instances to launch. Then we would be going ahead and creating RDS parameter group where we will give all the parameter values that are required as part of our RDS provisioning. Then finally, we will go ahead and configure the RDS instance properties and arguments and launch it accordingly. Now let's go ahead and see our first overview, that is AWS Relational Database Service. So what is AWS Relational Database Service? It is a fully managed database service that supports relational database engines such as MySQL, PostgreSQL, Oracle, and Microsoft SQL Server. So if you go ahead, if you go to the AWS console and if you go to RDS, okay. So in this, suppose if I click on create database, after you see, these are the engine options that it supports, right? This is MySQL, database, PostgreSQL, Oracle, and Microsoft SQL. So these are all the offerings that it offers. Now, it simplifies the database administration tasks like patching, backup, scaling users to focus on application development. What we mean by that, if you see over here, if you want to export the backup of your specific database, you can export it by the option that we have over here, that is exports to S3. You can also set up automated backups. You can also actually define your maintenance window for the specific database instance that you have launched, so that if there is any upgrade in terms of engine version, so it would be done as per the specified time in the maintenance window that you have declared. Now, the third point is it provides high availability, durability, and security for databases. So in terms of security, whenever you are creating relational database, it helps you store your password in secret manager, and that password can also be rotated based on the policy that you have. So that provides a very good security in terms of your database credentials, your secret credentials that is been that you have to store. Uh, and you can also add KMS keys, secret keys, and if you are storing the data, you can encrypt that data. So there are many more uh, functionalities that RDS offers. Now, let's see one quick overview that how this kinds of RDS implementation are done in a production environment. So over here, I have just, you can see that there is one VPC and there is one single availability zone. And in that single availability zone in VPC, we have 2 subnets. One is public, one is private. So usually RDS has been launched in private subnet. The reason for that is we have to keep it secured with minimal people logging onto it and doing any changes, because database is the heart of your applications. So any changes to that tampers a lot of uh, data. So that is the reason it is kept in a private subnet, and it has an appropriate security group based on which the incoming traffic is tightly controlled. So this is the kind of setup that you will see in the production environment, where if the people wants to access the private subnet, there would be specific jump servers or there would be specific EC2 instances which would be available to connect to that specific RDS instance. So it won't be public to everyone, but yes, you can connect it in different ways. If you want it to keep it public, you can do that also. But this is the kind of implementation that you will see from small application to bigger application, and it expands based on the requirement. So right now you can see only one subnet, but if somebody is having multiple availability zone, multiple master nodes, so in that case it varies. Now, let's go ahead and understand what is our first prerequisite. So the first prerequisite is in your AWS account, make sure you have one custom VPC created along with the internet gateway and a custom route table and associate that specific VPC in the internet gateway. If you don't know how to do it, I have already, as part of this series, the part one is going to help you to create the VPC internet gateway and associate them. I will put the link in the description above. Now, moving forward, understanding our second prerequisite. In second prerequisite, what you can see is you have to create one public subnet. So as part of prerequisite one, VPC main route table and internet gateway, this has been created. Now you have to create a public subnet and a custom route table, and you have to associate them. Why you have to create this? Because we have to deploy our RDS instance, and subnet would be required for the same. If you don't know how to do it, as part 2 video of this specific series, I will put the link in the description above. You can go and refer that specific video and you can deploy the specific public subnet for our use case that we are going to implement today. Now, moving forward, I would be talking about the three basic files that we always vouch for whenever we start our development. So let me jump back to our Visual Studio Code. So in Visual Studio Code, you will see I have three basic files. The version file, where I have defined the version is greater than or equal to 0.12, that is the Terraform version. Then as part of the provider file, I have defined my region, that is US West 2, Ohio, and I have given the link to my AWS credential files. So either you can use this link or you can put in your access key over here based on the uh, based on your comfort. So moving forward, let's see what we have in the variables file. So this is the variable file, and this is having a lot of variables that we are going to see step by step when we are going to explore our main.tf file. Now, so as we have understood the three files, let me take you ahead and help you know that what we are going to configure and deploy today. So we are going to create four resources: security group, RDS subnet group, RDS parameter group, and relational database service. So not relational database service, it would be RDS instance to be precise. Now let's do it step by step, one by one. So we will start with the security group for RDS. Now let's go to the main.tf file. So in this file, we will start from above. I will just maximize this for you guys. Yeah. So security group for our RDS instance. That is, yeah. So in this, what we are doing is we are providing a name of the security group, we are providing the description, and we are providing the VPC ID. This is the same custom VPC ID that was part of our prerequisite. Okay, and this VPC ID we are fetching by using a data source, and that data source we have mentioned over here. This data source is going to fetch our custom VPC ID by using the tag that is name is equal to custom VPC, and we are calling this specific data source over here, and we are passing that value to the VPC ID. So these are the basic arguments that we have looked now. Now let's go ahead and see what is the ingress port that we are going to open. So it is 3306. Why? Because the specific database that we are launching as part of RDS is MySQL, and it requires port 3306. So we have enabled that port, and for outbound traffic, it is flow to all. And this is the tag that is uh, the tag that we have mentioned for the security group is RDS security group. Okay, so this is the first part that we have covered, where we have created a security group for our RDS instance. Now let's look at the second part, that is RDS subnet group. So as part of the RDS subnet group, it is a very small uh, resource with arguments where you just have to mention the subnet IDs where you want to deploy your RDS instances. So I have given the name as RDS subnet group and the subnet IDs. So it is subnet IDs. Here you can provide a list of subnet IDs or a single subnet ID. If you're providing it as a single subnet ID, just make sure that you provide it into this format where you can give your single subnet ID, whatever you have. Okay. But when you're passing a list, you can pass it in this way. So over here, you can see I'm passing a list. Now, how come I'm fetching this list? So I have defined a data source in my variable.tf file. So in variable.tf file, if I go down, you will see I have used a data source that is AWS subnets. In this, what it is going to do is it is going to actually fetch the VPC ID first. That is a custom VPC ID over here, which we have already described as part of our data source at line 5 to 10. Now, from that, it will get the VPC ID. Now, inside that VPC ID, it will start searching for the resource which are public. So right now we have just created public subnets, but usually when you do it in a production environment over there, you can create a private subnet and you can keep this value as private. So it will just look for the private subnets which are being created. If there are multiple private subnet, it will get the list of all the private subnets and you can use it accordingly. So Now we have covered our RDS subnet group creation. Now let's go ahead and understand RDS parameter group. So what is RDS parameter group? First, let's understand. So RDS parameter group is a collection of engine configuration. So the MySQL engine that we are going to use. So this is the configuration that you will see as part of the MySQL configurations. Over here, you will see we have mentioned the family. This is a required parameter for the specific AWS DB parameter group. You have to mention it. The name we have given as RDS parameter group and the description parameter group for MySQL. Now over here, I have mentioned two parameters, that is character set server and character set client as UTF-8. So before I move ahead, let me show you about the last resource. So our last resource was AWS DB Subnet Group. So this provides a RDS DB Subnet Group. You can see an example where if you have a subnet IDs that you want to mention, you can mention it as part of this specific list. Just make sure you mention the list, or if you're passing it as a data source variable, which is a list, which is returning a list itself, that can also work. So that is how you can use, and these are the arguments. And in that previous resource that we were looking, the subnet IDs was the required argument that needs to be mentioned, and these are the attributes that is been returned as part of this resource which has been created. Now, the current specific database parameter group that we are looking at is, so right now we were actually focusing on MySQL. So for MySQL, you will see there are multiple examples. So over here, I can see one example which says that character set is server UTF-8, right? Parameter. So these all things are defined as part of arguments. Now, see, and if you want to add a lifecycle to this specific parameter group, you can do that also. And if you want to understand more about the lifecycle, just click on this link. Okay, it will take you to the meta argument over here, lifecycle meta argument. Over there, you will understand that what exactly this does. So it says that whenever you're going to create delete this specific parameter group, so it will first create a new one, then it is going to create the one which is existing. So it says that whenever you are creating a new resource, first create a new resource, then destroy the existing resource. So that is what this parameter mentions. If you want, you can add that as part of your lifecycle also. Now, as part of this specific argument reference, you can see that the family is a mandatory. So you have to mention that as part of which family you are creating this specific resource. That is the reason we have added a family over here. So this is the mandatory parameter that we are using now. Now let's see our final resource, that is instances for your RDS. So let's first see what exactly this resource is from the official documentation. So this resource is AWS Database Instance. It provides an RDS instance resource. Now, if you see the official documentation, you will see a lot of examples. So as part of the basic example, you will see these are all the arguments which are being defined. Okay, but if you want to customize it based on your engine that you're using. So for example, if I see over here, you will see that RDS custom Oracle usage with replica. So this is the custom configuration that they have made for an implementation which has read replicas for that specific RDS which they are going to create. So over here they have created a data source where they have mentioned some data, and then they are utilizing that specific data into the resource block over where they are also mentioning out the timeouts. So whenever an entry is being created onto a specific onto the database, it says that for creation it should time out in 3 hours, for deletion for 3 hours, and for update also 3 hours. So you can also add multiple parameters based on your requirement. If you want to understand what all arguments can be used over here, on the right hand side of the official documentation, always see the argument reference. This will show you that what all things that you can do. So right now I am just speaking about the custom one for replica, but for for SQL Server also, you can see that there are many more options that can be added over here. So over here you can see that multi-availability zone. So for multi-availability zone also, if you want to keep it in different availability zone as part of a read replica, or um, uh, having more than one masters, you can do that also by using multi-availability zone. And the instance class you can define, where you can define what kind of instance you're going to create. So what is instance class usually? So whenever you are creating a database, at time of creating database, if I create on my SQL, it is nothing but this, the kind of instance that you're creating. So now let's go ahead and understand each and every argument step by step. Okay, identifier is nothing, just the name of the RDS instance. Okay, so from where this is coming, so let's go ahead and see few variables that we have defined for our RDS configuration. The first one is the RDS instance identifier that we have given as Terraform MySQL. The second is database name, and the third is database user. Now, going back to the configuration, main.tf file. Identifier, we have mentioned the variable which is mentioned over here, that is Terraform MySQL. Now, allocated storage. So allocated storage I have mentioned as 5. What is 5? Is it MB? It is KB? What kind of uh, storage option it has? So if I go here and click on allocated storage, oh sorry, allocated storage. So you will see over here it has been mentioned as, come on, yes, require. So if you see, the allocated storage is in gigabytes. So these are the gigabytes. So if based on your requirement, you can mention whether it is, for me, I have just kept as 5 gigabyte. You can have it at 500, 400 based on your requirement. Now the engine, as I said, we are using MySQL engine. Now the instance class, as I was showing over here, instance class is nothing but we are just using a free tier RDS instance that can be used over here. That is database T2 micro. So this is the RDS instance. Now, this is a special parameter, manage master user password. So as I have kept this password, manage master user password as true, then what is going to happen is whenever, so as soon as we are going to create this RDS instance, it is going to create this password for me, and it is going to store that password in the secret manager in an encrypted format, which provides very good security towards your credentials that you have for your RDS database. Now, over here, you just have to mention it as true. Nothing else is required. It will automatically go ahead and create it for you. And once your credentials are in secrets manager, it helps you to rotate that secrets based on your policy. So some companies rotate the passwords in 30 days, some in 60 days. So based on your company requirements. But this is going to help you to create your password. And if you are mentioning this as to, you don't have to mention a parameter which is db password, db underscore password, because your password is automatically going to be created from here. So I will show you once it has been created and how you can view and use it or change it. Okay, now the database name is nothing. The database name is Terraform test db, and the username is Terraform. Now, moving ahead, over here, DB subnet group name. So as part of this DB subnet group name, it is nothing but, if I go over here, this is the same, this is the resource that we have created, where this resource is having the list of the subnet IDs. That's it. So we have passed that over here. Now, if I go to VPC security group IDs, this is the security group that we have created at the top. This is our resource, and this is going to be attached to the RDS instance, which is going to be created. Now, final snapshot I have skipped. We don't want to create a final snapshot, and for final snapshot identifier also I have ignored, because as part of this tutorial I am not going to create any snapshots. So these are all the configurations that we have looked for and we have created. Now let's go ahead and start running our commands for Terraform to deploy our Terraform resources. So let me jump back to our Visual Studio Code, and over here I will just minimize the above code. No, but before minimizing the above code, I will just show you that we also have one important file mentioned over here, that is output files. What this file is having is, it is going to output the values that we have defined over here. So right now I have defined the RDS subnet group ID, the resources that I have created, that is database instance, database subnet group, and the parameter group. So it is going to give the value back when we are going to perform Terraform apply. Now, going back, we will start with the first command, that is Terraform init. So it has been initialized. Then we will use the command Terraform format. So no, all files are already formatted. We don't have to format anything. Then we have to write Terraform plan. This will tell us in case if we are facing any errors, it will let us know. Fantastic. We don't have any errors, and we are all set to deploy our resources. So let me just go ahead and write Terraform apply auto approve. So guys, now to create your RDS instance, see these are the outputs that it is showing right now. It's showing as known after apply. So once all the resources have been created, then and only then it is going to go ahead and show you what are the IDs or what are the names of that specific parameters that we have tried to output during apply command. Now Just a quick heads up, this creation of RDS instance takes around 5 minutes to 15 minutes. So for me, it took around 7 minutes or 8 minutes, but sometimes it also goes above that. So if it is taking time, you don't have to worry. It takes time for the creation of the RDS instance because there are a lot of configurations which are in place for deploying your database, which takes time because it's not only creating your database, it's also associating your database with the monitoring, and then patch management, a lot of stuff which are tightly integrated with the AWS RDS service. So let's wait for our resources to be deployed. So guys, this time it just took 4 minutes and 14 seconds for me, where you will see that the database instance parameter group and the subnet group all are been created successfully. Now, let's go ahead and verify whether all these resources are been created. So let's jump back to our RDS. Over here, I will click on databases and you will see our Terraform MySQL database is been created. If I see at the size, you will see that the size is DB T2 micro that I have mentioned, and the engine name is MySQL, and the region is US West 2. That is one of the region where we have our subnet been created. And if I click on this database, you will see that there are it has been associated to our custom VPC. It has also been associated to the two subnet IDs that has been returned as part of our uh, data source variable which was returned. You can see our RDS security group which has been associated with the RDS instance. So apart from that, you can also see our two security group rules which has been added over here. If I click on this, it will show us what are the rules. See, so this is the same rule that is inbound and outbound, and this is our Terraform MySQL DB instance, and this instance is created in US West 2B. Okay, so these are the basic things. Now, guys, uh, I will just show you as part of our overview. I shared one information saying that you can do a lot of stuff if you have your RDS being if you have your RDS instance onto AWS cloud. What all it helps you to manage. You can click on monitoring, and over here, but it will show you the monitoring of your all the RDS monitoring, like storage space, IOPS, that is input output, a lot of things. So this is one thing that you will get. You can also see the logs and the events which are available. So over here it will show you that the database instance is created, restarted, deleted, uh, whatever the events are happening, and based on this event you can also take some action. And suppose if you have to send some notification by using SNS topic, you can even do that also. So now moving forward, the other part is if I go on maintenance and backup, as I was saying, suppose right now you have the version uh, which is 15, but there is a minor version upgrade that is available. And if you want to, if it says that a version upgrade is available, then you can go ahead and set the maintenance window for that, in which the upgrade will happen. So it will not happen at any time. It will only happen at your specified time of the maintenance. And if you see in configuration, this is all the configuration that we have mentioned: the DB instance ID, then see the master username. Okay. Now, as we have came to username, now it see as part of this configuration what it says that manage in secrets manager. So it has actually created, if I go in AWS secrets manager, secrets, see this is the secret that it has created. Now if I go, so this is the secret where you will see the secret. If I click on retrieve, see the username is terraform testdb and this is the password. So this is auto generated. So this is how it helps you to secure your password. And as I was saying, if you want to keep, if you want to rotate your password over here, also you have the rotation policy. You can just edit your rotation, and based on that, you can mention what is the rotation policy that you want to set. Apart from that, if you want to fetch the data from by using a code, there are multiple options over here. They have given you can use embed this code into your code, that is Java, Python, or Ruby or Go, and you can fetch the value also, that is the secret value for the RDS database name while you are while your application is trying to log in to perform some activity onto the database. Now, so these are the things that have been created successfully. Now, just a quick heads up, just make sure that once your testing and deployment is done, make sure you run the command that is terraform destroy auto approve. This will destroy all your resources and you won't be charged for any extra thing that you have not done while you are away from your AWS account, and it gives you a big bill if you leave it as it is. So that's it for this session, guys. I hope you liked it. So as part of this series, we have covered RDS creation, and I have also showed you that how RDS is having a lot of collaboration with different services, where you can do monitoring, where you can do maintenance, where you can do patching, a lot of things. I hope you liked it. Last but not the least, I will just give you a walkthrough of our blog. So this is the blog that I have already written for AWS relation databases. So if you go through this blog, it will show you, say you that what is the prerequisites which are available. So for prerequisites also, I have a blog. You can mention, go through that prerequisites. Now, whatever file we are using, provider, variable, and the versions file, all has been mentioned over here. Apart from that, whatever we are using, so each argument, if you're using VPC ID, it will say that it is a mandatory VPC ID. So everything is properly mentioned as part of this blog. If you have not checked it out, I will put that in the description below. In the description of the video, you can watch it from, check it out from there. Apart from this, I also have a Git repo that I'm going to add in the description. This Git repo is having all the blogs and all the part of the YouTube videos that I have mentioned. So for example, suppose if you want to see the first YouTube video, you just have to go to this, right click, open in new tab, and it will automatically go ahead and it will start the video for you. So it is that seamless. So everything in one place, so that you don't have to go anywhere else. So that is what I have added over here. So it's, so you also have the Git repo. So if you go to this readme, just click on any of the repo that you want to go. It will directly take you inside that specific repo or the blog. So you have to just click on that, and it will keep on routing you. And these are the blocks. So these are the images. This is a clickable images. If you click on any of the images, it is going to open that specific blog. So everything is properly documented for you guys, so that it would be easy for you to take it further. I hope, guys, you liked it. Thank you for your time, and see you in the next video. Have a great day. Goodbye.